mention a little bit about the week's storminess over the southern states, Andrew, but I won't go into any detail because I'm in ignoramus about that, so you won't have to worry about that.
I mean, if you get to that point, John, it seems like a good break point. We can just switch screens at that point, too.
Okay, that might work. We'll see how it goes. Okay.
Yeah.
All right, so let me get my screen up. Oh, weird, it tells you what the definition of screen is. I already know what that is. Okay, so I should be okay, right? You see my screen? Okay.
Yep.
All right, so I guess I'm ready to go if everybody else is.
All set.
Okay, welcome to our weekly weather discussion. We were talking about what we'll do in the summer, and the summer will be an as necessary sort of on the call sort of weather discussion. The last one that will regularly be scheduled on Friday will be next Friday, and so we're almost at the end of the semester. So I wanted to show you the visible satellite imagery over the continental U.S. and adjacent waters this morning and this early afternoon. There's a couple of disturbances of interest. One of them is the one that's kind of roaring along in the Labrador Sea. If you can follow my cursor, it's up southwest of Greenland and then northeast of Newfoundland and Labrador. And so you can see the back edge of the cold frontal band here is really quite dramatic, and it extends for thousands of kilometers, unlike these miserable little tropical cyclones, which might be 300 kilometers across or something. This thing is an enormous scale, and it's going wild up there, although it's associated with a really intense upper trough, which we'll see when we get to the 500 millibar maps later on. And you can see underneath in the clear sky area of Quebec, there's a lot of snow on the ground still, almost all the way to the St. Lawrence River. And this is giving us a really nice view of that. Of course, there's a lot of pine trees and conifers of other kinds in this region of the world, and so you can see a little bit through the ground, much like the northern part of our state in the middle of winter. But there's a lot of snow still on the ground in the northern 4/5 of Quebec, probably the northern 2/3 of Ontario, and all over the Hudson Bay, probably still ice. So pretty cold and not that far away from us. But there's some of the main, one of the disturbances of interest. Another one doesn't look so well organized. But this is a storm that's just off the mid-Atlantic coast, and you can see some of these clouds, even the ones immediately to the southeast of Cape Cod and the islands, look convective. The whole thing on the eastern side is convective. There's been a blow up this morning across Florida. There's been the convective blow up sort of along the Gulf Stream there off the coast of the Carolinas, and that's been a pretty prominent feature. In fact, this storm and some of this convective activity dragged itself across southern Alabama, Mississippi, parts of southern Georgia yesterday, and we'll see that in the SPC Storm Reports in just a minute. And then Andrew Quigley will be telling us more about that and the complexion of the forecast challenge in that part of the world much of this week in a segment of the discussion today. So that'll be interesting. And then here we've got a system that's beginning to organize over Kansas and Nebraska. And we had a little bit of rain this morning, temperature around 39 and rain. It was like a Seattle, November day here this morning. The same was true in Boston. You'll see when we go to the surface office, it was 43 over 41 with rain, northeast wind, miserable. But that's kind of what's going on here across the central United States and the eastern half of the United States. Over the west, the sky is pretty clear, especially over the southwest. Really interesting clearing in this visible satellite image south of California, and you can see that the stratus edge is really sharp, and then there's ship tracks embedded within it too. So it's really quite an interesting satellite picture on that side of the continent today. And there's a light rain coming in on the Pacific Northwest coast. We'll see when we go to the radar. That's associated with a kind of a weaker storm that's making its way northeastward toward the coast of British Columbia. So that's the broad complexion of things this morning. I want to go first to the Storm Prediction Center and just a quick review. I'm not trying to steal Andrew's thunder. It was announced to me that he's going to give us more of a description, and he's certainly more expert about this than I am. But I want to just show you where the weather was interesting since we last convened on the 17th last week. We had some wind reports spread across the entire southern tier of the southern states on Sunday, the 19th, Patriots Day, and then a lot of tornado reports in Mississippi, the panhandles of Alabama and Florida, and a couple in Texas on Sunday. So that was pretty bad weather there. We had some more Floridian tornadoes on Monday, and then a more active day for hail reports and various other wind reports along the Red River Valley on the Oklahoma-Texas border on Tuesday. Then a deadly day on Wednesday, where tornadoes both in Oklahoma and in parts of southeast Texas cost lives. The same set of tornadoes went across Mississippi and Louisiana. I don't know off the top of my head if lives were lost in those storms, but I know in Oklahoma and in Texas some were. And then there's a widespread hail reports as well in the broad area, and then wind reports. And then finally, yesterday's weather brought much of that convective activity across southern Alabama and southern Georgia, with a few tornadoes in northern Florida, with wind reports, none of them high wind reports, which are 65 knots or greater, but certainly in the vicinity of the tornadoes along the southern strip here of Georgia, just to the east of the west of Savannah. It was pretty bad. And some big property loss. I think lives were lost also yesterday. So it's been a really miserable week across the northern Gulf Coast. And, of course, when you lose your home at a time like this, maybe it doesn't matter in Georgia since the state's open now, but it matters everywhere else that it's not a good idea to be outside and not really know where you should go, and you congregating in the normal relief centers where lots of people can get crowded in is not a good idea at the current time. So Andrew will tell us more maybe about what was some of the ingredients that brewed this. I want to say just one thing about that, and I want to make sure I go to the right place to do it. Yeah, the 500 millibar maps over the course of the week. So this is starting 12Z last Friday. And so this is before any of the active weather was really going on the coast, but you're going to see a series of waves. The first one was the one that we were talking about last Friday off the coast of California. And there it is. And watch how these things move across. So that one comes sliding across the desert southwest by, I'm trying to keep the dates. Let me see, I'll get a better view here, zoom out a little bit so I can see the dates too. Yeah, so you can see the dates as well. So here's the wave on Sunday morning, Saturday evening in Arizona. And here it comes across into East Texas and Louisiana by the time we get to Sunday night into Monday. So this is round one of severe weather. Meanwhile, tremendous upper front brewing over the chain of lakes, and that leads to a major cyclone that gave us a windy Tuesday. But watch this. So that one goes across with the first wave of not as intense severe weather and not as numerous in locations, but there's the first wave. Here comes another wave across Southern California and over the Arizona desert. And by the time you get to Wednesday, well, this is Wednesday morning, sorry. Here's Wednesday morning at the beginning of the outbreak over Oklahoma and Texas. Here's our upper level wave on the New Mexico-Texas border. And so,
John,
yes.
I was going to say that this pattern, although it's clearly a spring pattern, has some elements of it, particularly earlier in the week, that looks more like a winter type pattern with a trough over the east and the ridge over the western Pacific Northwest.
Yeah, I very much agree with that. And I think both of these waves that came across and ended up, being responsible in some part for the severe weather outbreaks were waves along the subtropical jet. So we're seeing just this kind of the underbelly of some of these waves at 500 millibars. They're more prominent at 300 or 250. So it's been a really interesting week of transition, because at the same time you've got this monstrously winter upper trough sitting over New England and maritime Canada by Wednesday morning. And that accounted for the intense cyclone there in the Labrador Sea that's just now beginning to wane. But you can see the baroclinicity associated with this upper trough is extraordinary. The cold air in the middle is at minus 36, minus 38 range. I think it's minus 38 at Portland. So that's about as cold as you get, at this time of the year. And certainly you might only get 6 or 8 degrees colder in the most intense part of the wintertime. So that's a really deep wintertime upper trough in late April. And then a more springtime regime, though having winter elements, as you point out, parading across the southern states and really wreaking some havoc. So that's the Wednesday wave, and there it goes across yesterday into yesterday morning. So there's more active weather that we saw that's moved up into New England, and some convection over Florida during the day yesterday. So a pretty interesting pattern over the last week. And that's all I'm going to say about it. Andrew may say more. I think it might be okay if I keep going with the current weather, though, because that current weather is not sufficiently interesting to occupy the hour this week. So we can go through the rest of this, and then Andrew, it'd be great if you could tell us a little bit more about your specific challenges in 453 this week and how you guys met them. So I'm going to go to the West Coast of Image next. And you can see some interesting, not so well organized weather in the Gulf of Alaska. There's a couple of little swirlies here. Here's one right off the coast of, right about at the latitude of Portland. Here's one a little further north, maybe the latitude of Nanaimo on the British Columbia coast, but well off to the west. And if you go further south, here's our state of Hawaii, and you can see a train of moisture coming all the way from the subtropical central Pacific right up towards the Pacific Northwest coast. And in fact, this little tendril of it that comes across Portland and Seattle is why we'll see on the radar in just a minute that there's rain along the coast.
Hold on.
Yeah. Uh-huh.
Maybe you're going to mention it. Maybe you're about to mention this wondrous
You're
thing.
going to cut me off. You were going to cut me off. Go further south and look what you see down here.
Yes!
Is this what you wanted me to mention?
Yes!
Yeah, I noticed that. So here's a beautiful cluster of convective events along the ITCZ. Really nice. They seem to be organizing. I'll say what the National Hurricane Center has to say about it in a minute. What struck me about this was, first of all, it's the largest convective cluster on the whole ITCZ, and you can see it right away. Then the anticyclonic outflow is so dramatically obvious at the top of this cluster that one imagines it's gaining a circulation and a warm core. Otherwise, how could you really explain that? So that's a pretty interesting development, and it's wildly convective. You can see it's kind of blown up all over the place. It's in its nascent, perhaps nascent organization stages. The Hurricane Center is saying there's about an 80% chance of cyclone formation in the next 2 days. Right now, what do they say about any winds? They don't even know about any winds. It's a broad area of low pressure, about 800 miles south-southwest of the southern tip of the Baja Peninsula, and they're going to update again later today. So it's a pretty interesting feature. I'm not sure if this breaks any sort of records about earliest tropical cyclone in the Pacific Basin, but April 24th strikes me as pretty early. So
right. The normal, the average, or the, official start for the season, I believe, is the 15th of May for the Eastern Pacific and the 1st of June for the North Atlantic Basin. But this is, I'm not certain this is a record early start, but it certainly is interesting and exciting. It's the most conspicuous, interesting thing in the satellite imagery anywhere in the Eastern Hemisphere between 5 north and 25 north and 100 west and 140 west.
Could you get less specific?
Twitter, I think posted that there has not been a tropical cyclone in the North Atlantic in April, so this would be the first, if that's accurate.
Yeah,
Pacific,
this is the Pacific Basin.
Pacific, you're talking about? Pete?
Yeah. Yes.
Oh,
okay.
Well, that's really interesting. Yeah. And it looks like it's well on its way to becoming something of interest because it's a pretty interesting looking convective cluster down there. So yes, and I noticed that on my own, Michael. I didn't even have to have you come down the hall and tell me, did you see what's going on in the Pacific? I feel kind of proud of myself about that. But so that's
typically I don't look at these specific shots, but as you were describing it, I looked over and saw the edges of the clouds. Like, wait a second. Immediately went to the Hurricane Center page and saw the X. So you spotted it before I did, which indicates you're beginning to warm to these sorts of events, which is great. Good news for everyone.
They're sort of a dime a dozen. They're small scale, so you want to pay attention to them as best you can. So, so that's interesting. No doubt, that's the first thing. And when you look at the whole Hurricane Center page across all of the different basins, this is the only thing that they have an X on. So it's pretty neat. There it is. Swirling away in the Pacific Basin south of the Baja. Okay, let's take a look at the surface map next. And we'll start in New England. I mentioned Boston was kind of having a miserable day. Look at that, 43 over 37 in light rain with a northeast wind, actually 15 knots, probably howling if you're at the coast. It's a little bit less wind at Provincetown, but they don't give you any other information. That's enough. You report at Provincetown the wind's off the water. Don't bother to come. There's no reason to be there that day unless it's July or August. So 49 over 48 over the islands, raining in Providence, raining in Hartford. So kind of a miserable day in Albany, kind of a miserable day in the Northeast United States. And it's widespread. The rain extends all the way from, the Baltimore metro area all the way up to almost, southern Maine. And there's light rain or ice pellets maybe at Halifax. So a pretty ugly day. And then when you go further south, that's when you end up in pretty nice temperatures, mid-70s, dew points in not excessive, but reasonably, 54 in Atlanta is not so bad for a dew point. You go further down Peninsula, you get to a 70, 73 at Tampa, for a dew point, 71 for Miami. So then it's getting a little bit less comfortable, but still
Yeah, John.
nice. Yeah.
Just a comment. I wish I had the statistics at hand readily, and maybe someone else has them. But I believe Miami has been experiencing perhaps its warmest April ever, getting to 94 already in the month, I think, multiple times. So this has been really unusual. Pete,
that is interesting. Have those warm days been low dew point days? Do you know?
Don't know. I would guess not, but I'm not certain about that.
Yeah, because I'm going to make a guess here. Now, one of the things about the high dew point down there is that it comes with haze particles. And if you don't have as much pollution in the air, maybe the haze particles are just a little thinner, and that gives you an extra 1 or 2 degrees of warming. I don't know if there's any connection at all, but wouldn't that be interesting if that were partly true?
Yeah, that's part of it, but I think the entire fall through winter has been just well above normal. So it's
is that right? Okay.
Yeah.
Jonathan?
Yeah.
This is Brad.
Brad.
Actually, right now, there's all sorts of biomass burning on the Yucatan Peninsula that's filling the whole Gulf of Mexico. So it is not, there's lots of pollution down there.
Okay, rats. So it's something else
Sorry.
intervened. Yeah.
Yep.
Something else intervened.
The planet's still emitting.
Okay. That's interesting too. So that's a great comment.
And Scott just typed in the comments, I'll just read it from Brian McNulty, regarding Miami. April 24th is now the 15th day this year with a 90-plus high in Miami. The previous record by this date was 8 days. It's also the 9th day with 92 degrees Fahrenheit or higher high temperature. The previous record was 2 days.
Wow, that's amazing.
So they're cooking down in Miami.
No kidding. That's amazing, huh? And Senator Rubio says you can't pass laws that'll change the weather. So that's he's got that figured out. So.
All right, and Andrew Winters just notes 97 this past week.
Wow, that's got to be their all-time April record, I would guess.
I would think so.
Close to it. Yeah. Wow, that's amazing. So that's a very interesting story, and the pollution from the Yucatan fires is very interesting too, Brad. I couldn't see that on any of the satellite. I must say I don't often look at the visible, which I think would have been easier to understand.
John, if you look at the Gulf color visible, it's pretty striking how much smoke.
Oh, is that right?
Yeah.
Okay.
One you don't like to look at, but that's okay.
Yeah, I don't usually do that. It's too bad. Okay, so lots of interesting things on the descriptions of things going on. Here in Texas now, this is kind of interesting. There's a wind shift line across the central part of the state. You can see southwesterlies and southerlies to the east, and then northwesterlies to the north and west, and dew points drop. So there's a nice dry line. Something's analyzed across the state here, where the dew points go from, with the exception of this station here, where it's kind of right on the boundary. Dew points in the mid to high 50s, suddenly they're in the 30s. The escarpment is here too, so there's an elevation at play, but it's not only that. So it's because it's troughy as well. So there's a lee side trough / dry line feature that's putting itself together in West Texas that's kind of nice to look at today. Further to the north, we're 44 over 37. It's brightening a little bit. I wouldn't say it's fully overcast now. This map's about an hour old, but it's getting close. And you can see further to the west at La Crosse, it's kind of partly cloudy only, so that's not so bad. And we may see some of that, but the temperatures really aren't going to move too much today. And it's raining to our west. We'll see in the radar reflectivity in just a minute as this cyclone that sitting here in far southwest Oklahoma, maybe it's kind of spread out along this boundary, is trying to get itself organized, and we'll see in what way it's getting organized as we go to some of the other charts. I'll be there in just a second. And then along the west coast, pretty nice day along the Bight. Temperatures in the mid 70s, dew points are low. That's commonly the case. A little troughiness in the middle of the valley. And then it's raining in the Pacific Northwest along the Oregon coast. And there were at earlier times a few reports of rain in south of the Puget Sound, but they've gone away. So now it's mostly along the Oregon coast, and that conforms with what we saw in the satellite picture as well. So that's nice. I wanted to next go to, where did I put it though? Oh, the radar summary across the country. So here's the convective activity across the midsection of Florida that we can see, and it goes to about 12:21 p.m. Central Time, so it's fairly recent. And then light rain across southern New England, and probably a little bit more extensively than is actually indicated here, because we're getting out of the radar range. But states of the southern New England states are going to be rainy all day long, so it's kind of a miserable day there, and some also in central and eastern New York State. Here's the complex of of weather associated with the cyclone that's trying to get itself organized. As I said, from far southwestern Oklahoma up to about Kansas City is where that thing is centered. And it's trying to put itself together. And as it does so, the precipitation's been filling in during the day. I think part of that is because the dew points are relatively high, mid-50s or higher in some locations. And there's been intermittent sunshine to the south. So that's been able to cook up a little bit of maybe potential instability, maybe even conditional instability. And here's a little bit of precipitation that gave us our shower. It doesn't seem, actually I don't capture the shower itself this morning in this segment of the radar, but you can see that's the bit of the precipitation that was associated with that. And then some open cellular, small cellular, cloudy convection across the western Great Plains, northern plains, I guess I should say. And you can see that across southeastern Montana through northeastern Wyoming and western Nebraska. And then here's that Puget Sound precipitation earlier in the day, and then now it's kind of relegated to the south coast of Oregon. Okay. One last thing is just to get a sense of what the upper level chart looks like now. I think I go one more to get to 12Z. Let's see. Yeah, here it is. This is 500 millibar map this morning. And for us, a sort of flabby flow. The winds are weak at 500 millibars. The geopotential height gradient's weak. The baroclinicity's weak. So everything's kind of bland over the central part of the country. That, I think, accounts for the fact that whatever's trying to get organized across Oklahoma and Kansas is going to really struggle. There's a little bit of a wave and a jet max out across the Colorado-Utah border, and whether or not that develops into a decent upper trough is yet to be seen. I actually have seen that, and I think the forecast suggests the storm develops well to our south and races across the continent to the east, but doesn't really affect us as looked like might be the case earlier this week. So that's about what I have to tell you about the current weather. And Andrew, maybe it is a good time for you to tell us a little bit about, well, I'll have one last point I wanted to make. I mentioned it as I came on. Monday would be the mean day at Truax for our first 80-degree high temperature. Monday, the 27th of April is the mean day. The latest ever was June 10th, 1997. I was blown away when I heard that. So we don't seem to have an 80-degree high anywhere in the near future. It looked like maybe next Friday could be a relatively warm day. I don't know exactly how warm it might get, but we'd be at least into early May before we get our first 80 of the year here in Madison this year. But I was astounded to know, or to learn that the latest ever was June 10th, and that was 1997. That's hard to believe. So 80 degrees may be a far-off wish for us in Madison, but not as far off probably as it was in the summer of 1997. So that's it for me. Andrew, would love to hear from you about what happened this week in 453 and what happened in the weather. So I'll surrender the screen.
All righty, Dr. Martin, sounds good. All right, so I'm just going to pull up my screen real quick. Can you guys see my display?
Yep, we're all good. By the way, Andrew Quigley is a senior in our department. For those of you who don't know him, he's in our mesoscale forecasting class 453 right now, and he's going to share. They were doing some virtual storm chasing this week, so I'll let him take over.
Yeah, thanks, Pete. So as Dr. Martin kind of showed a little bit in his review of the weekly weather, we had a pretty active day, particularly on Wednesday of this week across the southeast United States and southern plains for severe weather. And with 453 going on this spring, provided a really interesting opportunity for the class to kind of get to work with an alumni, Luke Odell, who has extensive knowledge related to supercells and tornadoes. And it allowed us to work with him and try to see if we could maybe put together a mock virtual chase. He wasn't able to get down to Oklahoma, but given that we're in the middle of our severe convection unit and talking about supercells and derechos, it was just a really good opportunity to kind of put everything we had been learning in lecture kind of together in the real world. And also just a really interesting experience for myself. I've been doing research with Dr. Tripoli for the last year and putting the finishing touches on a senior thesis on regards to supercellular tornado genesis. So with all the reading and stuff I've done in the last year to do this project, it's been interesting this week to kind of see my forecasting skills come together a little bit as well. So what I have shown right now are the Spc Storm Reports from this Wednesday. And I guess the first thing I would call our attention to is there's really two distinct clusters of wind, hail, and tornado reports. One that kind of initiated with a cluster of convection across eastern Texas that then moved across the southeast into the late afternoon, evening, and overnight. That gradually evolved into kind of a straight line wind event, mesoscale convective system. And then we have this cluster further north into Oklahoma. And this was kind of an afternoon, early evening type localized outbreak of supercells and tornadoes, pretty much right along the I-35 corridor, just to the north of the Red River border with Texas. And we had a briefing on Wednesday morning with Luke, and it was an interesting conversation because we had this convection kind of, I guess, initializing in southeast Texas that would then move through Louisiana and the southeast overnight. And it created a unique situation because, we weren't really sure if, with the presence of the convection across southeast Texas, if we were going to get the necessary moisture advection and boundary layer destabilization into Oklahoma to get tornadoes in what would otherwise be a favorable environment. So I just want to walk through some of the brief basic archived analysis that made southern Oklahoma in particular so favorable for tornadoes on Wednesday afternoon. So what we're looking at here are just some of the analysis charts from the Storm Prediction Center, and I'm going to be showing you just that 12Z Wednesday morning. So really kind of the 6 to 12 hours time frame out from this event. And really the key, I guess, kinematic trigger for this event was a shortwave ejecting out from the Rocky Mountains. And this, throughout the day on Wednesday, basically tracked due zonally from west to east across the Red River Valley and the prevailing largely zonal flow aloft. But as this feature at 500 millibars moved across northern Texas and southern Oklahoma, you had a westerly to southwesterly flow aloft. And when you look into the lower levels of the atmosphere, we're now looking at 850 here. We're looking at height contours. It's a pretty busy chart, but height contours in black. In the green contours, we have dew points above 8. And then we're looking at the wind barbs and temperature once again in red. And we can see out ahead of this mid-level feature, kind of the Rockies, we had pretty much due southerly flow out over central Oklahoma and north Texas. And that was particularly intriguing, one from a standpoint that we had a corridor of lower tropospheric moisture advection Wednesday morning that was going to be there to potentially destabilize the boundary layer later into the day across southern Oklahoma. But also with the westerly to southwesterly flow in the mid-troposphere, this kind of turn of the wind with height is incredibly conducive to rotating updrafts in any convection that does go up. So given kind of the thermodynamic support valve with the kinematics coming in from the west, it was looking, if we could get this moisture up into southern Oklahoma, that we were going to have a favorable setup for tornadoes in specific. If we go to the surface just to look at what the surface analysis looked like Wednesday morning, the one thing I've noticed, and I guess I haven't had a ton of time to look back at the data, and I'm sure Dr. Martin could comment to it, but the overall synoptics of this situation, to me at least, if you're looking at just a cyclogenesis standpoint, they don't seem overly great. I mean, the 500 millibar feature is pretty, stacked atop this. It's displaced slightly to the west, but it's really not the overall structure you'd look for an explosive cyclogenesis event. And it should be noted that this surface low, as it moved to the east as the day progressed on Wednesday, it didn't really deepen any more beyond 1,000 millibars. And I think that might have been in part due to just the lack of communication with aloft. And I don't know if I would say lack of communication, but just, structure. I've seen better structure with certain cyclogenesis events, which is probably why this surface load didn't get too deep on Wednesday. But the interesting thing with it at the 12Z surface analysis is you can see out ahead of the surface cyclone in Texas, we've got mild temperatures, but predominantly this high moisture, high dew point air. And we can see that we have a bit of a dry line feature at 12Z Wednesday morning, really kind of extending from far southwestern Oklahoma down through western Texas, and then out behind that you can see the dry line is broken. And this feature got caught up in this surface cyclone as it moved to the east during the day, and it kind of became the focus mechanism for severe weather, particularly supercells and tornadoes in southern Oklahoma on Wednesday afternoon. Now, I want to go back to the SPC page, and I wasn't able to pull up extensive mesoscale analysis, but as of Wednesday morning and past like the lunch hour on Wednesday afternoon, we had this interfering convection across southeast Texas that was eliminating like high moisture advection and temperature advection off the Gulf. And there was some doubt Wednesday morning and Wednesday afternoon if we were going to be able to get enough moisture advection to destabilize the boundary layer sufficiently in southern Oklahoma to fire the convection that ultimately produced all of these tornado reports near and around Ardmore. And what we had noticed in our 453 discussion, and I'll pull it up. So what I have here is a GIF from Wednesday afternoon from the SPC meso analysis, and we have temperature isotherms in red. We have CAPE in the kind of like green, yellow shading, and then we just have our surface pressure analyses laid over the top of all of that. And as the cyclone kind of moved to the east on Wednesday afternoon, we were noticing at our noon briefing that there was a very, very narrow corridor of moisture that was potentially going to get around the convection in southeast Texas and up in to southwestern Oklahoma that might give us enough thermodynamic support to kick off these storms. And it's hard to tell from this GIF, and I'll pause it so we can step through it. So this was at 23Z, so if we move it back earlier into the afternoon, you can see at 19Z, so 2 o'clock in the central time zone on Wednesday afternoon, we had our surface cyclone right along the Red River. And really this region of high dew point air never gets up into Oklahoma because of the convection holding it across southeast Texas. But what I'll call your attention to is this area of slightly lower dew point air that was sneaking in and around behind this interfering convection, yet out ahead of the surface cyclone, so ahead of the dry line. And it was this source of moisture in this very, very narrow corridor of moisture that ended up getting into southern Oklahoma and provided the destabilization necessary of the boundary layer to get surface-based convection. So basically just storms that initialize with surface-based parcels. And in the case of the prevailing flow aloft, we had rotating updrafts and supercells across southeast Oklahoma. And it was right on the edge of this moisture surge, interestingly enough, where all the supercells went up in southwest Oklahoma. And I would suspect, and someone can chime in and confirm if they think I'm right, or maybe suggest otherwise if they're seeing something else. But I think the reason why the convection was so focused in southeast Oklahoma is because we had the passage of this surface cyclone very nearby, and I think having a favorable convergence field in the lower tropospheric mass field, I think helped to bring air together, and with the prevailing thermodynamic support was able to lift discrete cellular convection and then produce rotation and tornadoes and supercells. The only other thing I wanted to show was out ahead of that moisture surge, the energetics of the environment. So this is another GIF over the afternoon time period on Wednesday afternoon. If I rock it back a couple hours. So what we're seeing here are red contours of mixed layer CAPE. And mixed layer CAPE is effectively looking over the lowest 100 millibars of the atmosphere, and it's trying to just give us the best idea of the available potential energy for updrafts to acquire, but accounting for some boundary layer mixing of the energy and momentum that might be going on. So we can see at 1 o'clock Wednesday afternoon, kind of right at the head of this moisture surge, we have a pretty pronounced instability gradient in the near vicinity of where that surface cyclone had been noted. And I should also note the blue shading is convective inhibition, so effectively the energy you'd need to overcome to produce convection. And the supercells themselves fired about 3 or 4 o'clock, so we're about 2 to 3 hours ahead of where that convection initialized. So as we move over those next 2 to 3 hours, you can see as the surface cyclone combined with that moisture surge immediately to the east of the dry line, moved across the Red River, we started to erode the sin barrier across southeast Oklahoma. And I think combined with the low tropospheric mass field convergence and this very, very narrow pulse of energy coming up from the Gulf of Mexico, it was enough to collectively bring the atmosphere to free convection in a very localized area that just happened to be highly conducive for rotating supercells, which, if I had to give my 2 cents, would explain why we just had such a really just localized outbreak of severe weather, but potent nonetheless. And it was pretty well covered by the national media. So very interesting day. And then as we moved into Thursday, there was a threat zone. I don't really have any data on Thursday, mostly because this evening event across Mississippi continued to track across Alabama and into Georgia throughout the overnight hours, early morning of Thursday. And it, I guess, robbed an otherwise favorable environment further to the north across Mississippi and Alabama from perhaps doing something that we saw in Oklahoma on Wednesday. So I don't really think it's worth talking about yesterday, especially considering how exciting Wednesday was in Oklahoma. So absolutely an exciting week as a 453 student and tornado fan myself. And I don't know, I'm hoping we can get a couple more days like this and we can keep these tornadoes out of populated areas. But looking at the prevailing flow into May, I don't know if we're going to have any extensive severe weather outbreaks with what looks like is going to be a pretty extensive upper level ridge in place across the central part of the continent for most of the month. So, but yeah, very interesting week.
Andrew, great presentation. Absolutely stellar. And John Martin here. I just wanted to make a comment about your earlier one about respecting the upper level low. You're right. The upper level 500 millibar wave is very weak. Now, things that work to the advantage of the environment, given an upper level weakness in the flow, is the fact that the stratification is probably quite low. And even the convective inhibition was on the order of 50 or 100 joules per kilogram or something like that. It's not very large. But I'm wondering if, what is this a reasonable proposition that the weak ascent that's forced by the upper trough is enough to prevent the buildup of any substantial convective inhibition, so that if you do have this punch through from the south of really, high water vapor content air and low stratification air, that you can just blow things up quickly in such a spot near a cyclone center because you have the surface convergence. Is that a reasonable way to look at that?
I mean, that's kind of the way I've been looking at it as I've kind of taken, quick looks over the data from the event. And that was kind of my hypothesis on Wednesday afternoon as well. I was thinking Southeast Oklahoma was going to be big, and Luke and the class were kind of in agreement as that would be the place you'd want to be. And the SPC had actually shaded the highest threat for tornadoes further to the south across Texas. And we had kind of reached a conclusion that we maybe thought they were underselling the convection across southeast Texas in that forecast, and maybe not appreciating the passage of the surface cyclone further to the northwest across Oklahoma, combined with, like you were saying, that kind of weaker forcing in the mid-levels of the atmosphere. So yeah, I mean, that sounds like a reasonable kind of handle of the situation to me, because I've been thinking similar myself.
Thank you.
Yeah, thank you.
Michael, do we want to go to the forecast, or do you want to show that Gulf loop first?
Well, I think you can show the Gulf loop first, and then I'm all set for the forecast.
All right, hang on 1 second here. I've got it.
So Pete's bringing up a loop that's generated or motivated by Brad Pierce's comment about the smoke over the burning over the Yucatan.
Wow, look at that. Amazing.
This is, so here's the Gulf Coast, Louisiana, Mississippi, Alabama, Florida. And if you go farther south than Cuba, and there's the Yucatan Peninsula. So just check out all the smoke emanating from here and getting sucked right into this convection over here. The other thing I noticed about this, I don't know how visible it is on everybody's screen, but look at the dirt along the coast, the dirty water right along the coast. Is that visible along there?
Oh yeah.
From the rivers. And of course, John, your plains along the Mississippi show up pretty well.
Yeah, and that's the big muddy that's emptying into the Gulf of Mexico. So that's the way it is.
So anyways, just a quick view of that. I will turn it over to Michael for the forecast.
Okay, thank you, Pete. and good afternoon. And also thanks, Andrew Quigley, for a really wonderful discussion. I'm going to share my entire screen, so hopefully this doesn't get messy. First, starting out, we're going to go backwards. We do adjoint stuff, but this is going to be backwards in terms of the longer term forecast, just so we don't get too excited yet about a warm up. This is the 6 to 10 day temperature probability outlook put out by CPC, I believe earlier this week. This is valid from the 29th of April through the first few days of May. And again, the colors show the probability that you'll be above or below normal, not the depth of the color does not indicate at all how cold it will likely be. And you can see for the northeastern part of the United States and the Midwest, over the Great Lakes in particular, below normal temperatures are likely. Whereas over the southwestern part of the United States, the forecast seems to suggest significant warmth. And I would say this is, Andrew was talking about a ridge over mid-continent. This seems like this is a little bit shifted further to the west. If you could have imagined what the long wave pattern might look like, about 500 millibars and above, this might have more of a trough in the eastern part of the United States during that period. But that's talking about May. But you even go further into May. This is from the 1st of May through the first week of May, basically, sort of a continued lack of warming up for us, it seems, with likelihood of our being below normal, and the southwestern part of the United States being above normal, and the Florida remaining warm in this scenario. The outlook for the month ahead, and we'll come back to this. This may be revised by the time we get to the beginning of next month, last weather watch of the semester. But this is suggesting for the month of May, basically below normal temperatures. Not below normal temperatures, near normal temperatures, not much of a signal for the central part of the continent. And then, again, this is a forecast that was put out about a week ago for the month ahead. And this is the 3-month forecast, basically May through July. Again, maybe slightly above normal, or above normal perhaps, but the probabilities are relatively low. Precipitation-wise for the period, again, wet in the east for the next 6 to 10 days if this verifies. And above normal, I should say. For our area, it looks like just about normal to maybe slightly below normal with the likelihood of precipitation. And again, a pretty close to normal spring in terms of precipitation for the month of May. And the 3-month outlook may be above normal for the Mississippi Valley and through the central part of the Midwest into the high plains out toward the Dakotas. So that's the outlook. It looks like the contrast in temperatures, certainly for the month of May, we're going to be pretty close to normal. So average temperatures. Next, we'll go to what we normally start off with, which is our meteorograms. And we have an updated meteorogram look, thanks to Isaac. This is really great. This is this is from our WRF model output that we've just started to run. And we'll be off later on in the summer transitioning this to maybe even higher resolution run with multiple runs during the day. But this shows the temperature trace. This is the upper one. This is in degrees Fahrenheit. So basically, this forecast is suggesting taking the raw model output. This has been post-processed, but temperatures getting into the middle 50s, maybe even a bit warmer than that on Saturday and today and Saturday. This is only out through 48 hours, with dew points staying in a pretty comfortable range in the 40s, 30s, and 40s for dew points. The next chart below shows the cloud fraction. Those are the blue dots. And you can see the cloud fraction is forecast by the WRF model. And I have to learn better. We'll have some descriptors for this. But thanks to Isaac for putting this together. Going from pretty much overcast to maybe some breaks in the clouds when we go through the weekend, and maybe even more sun by the time we get to Sunday morning, excuse me. And winds generally light out of the east, and an east wind this time of year often pretends that we're going to be, stay kind of, coolish with winds off the water, and certainly cooler as you get toward Lake Michigan. And then our precipitation forecast, a little spike in precip in the first 3 hours of the forecast, but pretty much no more accumulated precip for the rest of the period. So this is suggesting we're going to get, and this is in millimeters, not inches, so this is really very light precip forecast for during the period. Just to go back to the more common one that we've seen, same sort of story going through 60 hours for the from the MM5 forecast. You can see basically near constant temperatures today, tomorrow, and Saturday. Dew points drying out a little bit, and no precip is forecast, at least by the, this is in inches, by the WRF model. So a nice consistency, now an ensemble of forecasts. That's kind of neat. Let's look at the time height section. And here's a curious feature I want to talk a little bit about. I'm going to look at the forecast both from the perspective of the MM5, and then we'll switch over to the WRF, and then go to the Pivotal to wrap things up. So this is, again, our classic time height section. You can see yellow are the potential temperature contours. Solid blue is minus omega, so solid blue is upward vertical motion. You can see a little burst that gives us the precip that was forecast by the model earlier this morning. And then kind of subsidence over us. And then this really interesting burst of ascent above 500 millibars. So some stretching in the column. And you can see that stretching isn't balanced by any horizontal temperature advection. The column does cool off a little bit. You can see the isentrope sloping upward with time, which indicates a cooling, and that's kind of expected. But you don't see a tropopause depression passing by, which is kind of a curious feature. And so the question is, what's causing this vertical motion? And what I'm going to suggest is the convection that John was showing in the mid-continent this morning and early afternoon. The outflow from that is helping to generate a small jetlet that forms over the northern part of our state, and that helps to, this is basically a jet entrance region that's being created. Notice over us, we have southwesterly winds, and they go from westerly to strongly southwesterly around 18 hours, sorry, this is during the day tomorrow, so this is during tomorrow afternoon, you see this beginning to form. So that whole weather system that's propagating to our south, the convection in it, we're going to see a lowering of the potential vorticity in that region. In fact, I'm going to go back and forth between two different models just so you can see some evidence for that. First of all, we're going to look at the MM5 forecast, the 305 to 315 level. As we do this animation, and I should probably step through it, you'll notice the PV getting lowered over us. So this is the current time. Okay, you can see the edge of this trough, or the upper trough that's located over southeastern Colorado. If we go ahead to this evening, notice this broad area of lower PV. These are the light blue values from 0 to 0.3 PV units that are just passing over us by this evening. You can see that upper trough is now moved into Oklahoma, just past Oklahoma City, and Norman is to the southeast of that. But you can see this area of low potential vorticity, which I would claim is the outflow from convection. We'll go back and look at the animation again. And by tomorrow morning, this is spread across the southern part of our state, the edge of it just reaching Green Bay. Okay, so it's carving out a ridge over us. The superposition, if you will, or the encroachment of this low potential vorticity air, which I claim to be the outflow from the convection, with this approaching larger scale upper trough, the confluence of those two features is going to lead to an enhancement of the PV gradient, and through invertibility, we would expect to see an enhancement of a jet. And so we go to 30 hours in the forecast. You can see that. You can see over us, the winds have turned, over Madison have turned markedly from the south in this region. So you could argue that's also just indicative of a trough approaching. But if you look at the 300 millibar flow, this is at 200. This is at 300 at the current time period. Not much of a jet over us. I mean, there are westerly winds. We go ahead to 18 hours in the forecast. We see this jet beginning to form right over us.
Yeah.
Okay, and so there's a jet entrance type structure there. 24 hours into the oops, wrong map. I may have my timings off on this, so my apologies. You can see this strengthening jet over us, and you can see the ageostrophic flow, notably ageostrophic flow over us. Again, these lines of constant height, it would indicate a westerly geostrophic flow. And if you recall, we saw around 18Z tomorrow a strong southerly flow over Madison in the middle and upper troposphere. So I'm going to go back to 300 hectopascal. And you can see that, again, jet entrance region, as this jet maximum is sliding to our east. And again, I think this jet is partly due to the outflow from some of the convection. Being in this jet entrance region is going to give us a strong southerly ageostrophic flow in the lower troposphere. I think that's what we are seeing.
That's really interesting. I find that
it's kind of a muddled picture.
And when I
Sorry,
saw
John?
your, oh, what's going on with my feedback? When I first saw your cross section, I thought, hey, there's cold advection, and I wonder if there's anicyclonic shear. So if there's cold advection and anicyclonic shear, that also forces ascent in the mid-troposphere. And it's perfectly consistent with your interpretation, which doesn't use the same explanation, but it's perfectly consistent with it. Really neat.
So that's kind of a neat thing. So you're saying back to the time height section.
Yeah.
I mean, we're cooling off. This is at 18 hours in the forecast. So this is 30 hours in the forecast. And looking at the winds, the change in wind direction with height, we're going from, and this looks like warm advection. This is veering right in the lower troposphere.
Yeah, but from about 500 up, it's backing.
Right. So there's a slight backing there, so cold advection there. So this is just an interesting case. But notice that the vertical motion, if this is in fact a jet entrance region, which I believe it is largely, it's just confined in that upper troposphere. It doesn't extend down much depth. So
That's
just a really
interesting,
curious feature. And again, I think the evidence for diabatic creation of this, if you look at the loop, you can see this increasing area, at least from the beginning time, of lowering potential vorticity east of the trough. Some of it's advection, but some of that is also just lowered PV.
If I could expand on that idea a little bit, you even get the treble cleft structure in the PV, which characteristically is associated with occluded cyclones and the heavy snow and the occluded cyclone in the wintertime. The only way that it stays heavy snow back there is if you have a distribution of vertical motions that's intense through a deep column. And you have to get pretty decent mid-tropospheric vertical motions out of that, and you get it in the exact same mechanism that you're talking about. We're only seeing one piece of that because there's not really a better organized cyclone in the vicinity, but we're seeing the upper tropospheric piece formed exactly the same way. It's really, really interesting.
Yes, this is really fascinating. And then this is, I think, a clearer picture of the diabatic contribution of this. You'll notice the burst later on right there, this white area or a very light blue area that just appears. Yeah. And again, if this is all adiabatic, the flow, you're not going to see something like this occurring. So this is really a nice evidence for that. And if you look at the surface, there is a modest cyclone that eventually does emerge from this as it moves into the upper Midwest. You can see it moving across the central plains, and then it begins to deepen. But it's well to our south. That keeps us dry, relatively cool, not super warm. But if we get any clearing tomorrow, we could actually warm up just a little bit. So in the short range, that's the forecast from the MM5 model. If you want to look at the PV in the WRF, this is on ice, and this is on isobaric layers. Oops, wrong direction. If we look at the PV, this is the loop for PV. Again, a very similar story. You can see the lowering of the PV with these lighter blue colors beginning to spread over the southern part of our state as this lens of very low PV forms. It's not quite the same. It's very similar to that treble cleft structure, but maybe a little bit delayed in it. But again, you can see this very nice structure that emerges in this sequence of maps that Isaac's put together. And then looking at the surface map with precipitation, we're just on the edge of the precip. So this is showing the very light precip, and maybe change the scale just a little bit at some point. But there's the evolution of that cyclone. You can see it deepening to our south. There's a question or a comment. Okay, that's just Pete commenting on the maps that are these really nice maps that have been created. And if we go further down, just for people who want to look at this, and we can post the link to these shortly, right after Weather Watch, if you're curious about the maps when we begin looking at them. And this is the 3-hour precipitation on an intergrid. I believe this is a 9 or 10 kilometer intergrid that he has running for the upper Midwest, which is really nice. You can see the precip, and we can do a pseudo radar summary as well for this that we have attached to this. Let me just do that. Here's a composite reflectivity type of image as well. So this is what if you were looking at a radar, you would expect to see in the forecast. So nice job on those maps, and we'll continue to be making enhancements to them. If you have recommendations for products you'd like to see, please don't hesitate to ask. And of course, we'll always have those meteorograms. And it's amazing, John, the name stays the same.
Yeah, so, even with a revised package, which Isaac, great work, it's an opportunity to change the name to what it really ought to be, but you're just forsaking that. That's the only criticism I'd have. I'd go to meteogram, but that's all right.
John, you're
As
breaking
the-
up. I can't
as
hear
the
you. John,
Canadians
I
do.
can't hear you. I can't hear you. Okay. And so looking ahead, beyond 48 hours, okay, that cyclone deepens. Ridge begins to build in. This is in the GFS forecast. We begin to cool off. We have, the easterly winds, easterly winds. Cyclone moves into the mid-Atlantic and produces a late season wintry precipitation over Vermont and New Hampshire. That's getting pretty late April for such an event. But you can see a big warm up. Seems to be setting up for the plain states. I'm going to run through these pretty quickly. This is Tuesday with a southwest flow. Things sort of moderate temperature-wise, but we don't get super warm. Temperatures only in the 60s, as forecast by the. That's still actually cool. This is on Monday evening, excuse me, 0Z. We're just only in the upper 40s, low 50s at that time period. We go ahead to later in the week. This is Wednesday morning. We're at the same temperature, so that certainly suggests we were a warmer day. Tuesday, near 60 or so, and you can see for most of the week ahead, we stay relatively warm, but we have these surges of cool air coming in midweek as another cutoff forms right over us. So the temperatures for the week, this is just from the. Are you guys seeing the maps? I want to make sure you're seeing that.
Yeah,
this is the MOS guidance, MRF MOS guidance for the week ahead, and it actually shows our CLIMO is about 64 for the week. We have temperatures slightly above CLIMO and then kind of approaching CLIMO during the end of the week. Again, a chance of showery precipitation Tuesday and Wednesday if you look at the MOS guidance. And again, things dry up as we get toward our last weather watch at the end of the week classes. But this is MOS. You want to look at the maps. You want to look at diagnose what's going on. As the old saying goes, or I don't know, I made it up, but a forecaster on a roll gathers MOS. So anyway, I'll just leave that there. Here all week, folks. Here all quarantine.
I think that's best. Just leave that there.
Right.
This
But
is
again,
exactly in line with.
Yeah, I'm sorry, John.
I'm sorry, Michael. I was just going to say that the complexion of the flow in the next week is exactly in line with what Andrew said earlier about how there's not a chance of a severe outbreak. I think when you got a northwesterly flow across the central part of the continent, that must be a real killer on those things. And maybe there's one or two stations that are perfectly located where if you could say if the 500 millibar wind at North Platte or someplace in West Kansas, Wichita, I mean in Dodge City, has a northerly component, forget about severe weather in the plains. There might be such a simple empirical relationship because it is an overwhelmingly strong influence.
Great. So definitely. So that's where we're going to end. This is going to be by Weather Watch next Friday. If we'll see how this all verifies, big ridge over us and pretty decent weather. Again, if you take the modeled temperatures explicitly, which we all know that's not great, maybe about 60 by the time we get to Weather Watch time, and very likely getting warmer during the rest of the day. And you can see in the southwestern part of the United States, perhaps some of our first 100-degree weather setting up as well. So pretty decent week, showery, rain to our south over the weekend, and then maybe some showers during the middle of the week, and temperatures staying in the 50s and 60s, and maybe finally getting a little bit milder by the time we reach week's end. But nothing significantly, nothing cold and nothing super warm, certainly.
Yeah, not 80 degrees, and we're going to meet our median day on Monday, but we're going to pass it. So it's going to be, by that measure, a cooler than normal spring, I suppose. But that's a kind of an extreme way to measure it.
Right, and just for kicks, can't help but do this. Just looking ahead, I'm just taking some random times ahead, snapshots ahead. You can see this is the forecasted temperature in the CFS. Maybe we get to 70. I think we've seen 70s already. These are some 0Z times looking ahead. But 80 during this is now getting to the mid to late.
We haven't seen it yet.
Again, I've skipped some time certainly, and then this is going backward, if you will, with temperatures back into the upper 50s. Got the nighttime temperature.
Dr. Morgan.
Yeah.
I was looking at this model this morning as we kind of get that. I don't know if it's a ridge or exactly what you would call it. That just kind of seems to just hang out across the continent over much of May. But I was just kind of looking at some of those temperature readouts for fun, and there's a couple surges of warmth in the middle of May that get all the way up into North Dakota and Saskatchewan and Alberta. And there's suggestions that maybe you get into the 70s and 80s, and the climatology of the Dakotas and those southern prairie provinces in May, on average they're in the 60s. So I mean, there's the potential for some truly record warmth in May, and we won't really know until we get closer, obviously. But it's kind of exciting to look at mid to long range to see that you might have some surges of record warmth across the northern plains and southern Canada.
Right. So here's an example of that. This is the second week in May. Again, this is one model forecast. We could look at do forecast DT to see how things have changed. But you can see temperatures on this day. This is 0Z in the 80s in Saskatchewan and Alberta. So this is pretty significant warming. And the 500 milliwatt pattern that goes with this is a really convoluted one. You have this big ridge that's right over the Rocky Mountains, and a trough that extends in the northeastern part of the United States, and that seems to have some longevity. I mean, by middle the further out, we begin to get cutoffs along both coasts of the United States, a nice ridge over us, and the temperatures during that time period, we stay surprisingly kind of cool, but that warmth spreads. It's warmer to our north than it is over us at this time.
Man,
curious.
It's got to be something like that gave us June 10th in 1997 as our first 80. It can't be just a normal, something that's less convoluted, as you put it, than that. It's got to look something weird like that. But I'd like to go back and check.
Right, and it's always a mystery to me, or kind of an interesting mystery, that during the summer when we get these ridges over us, we can get it really warm in the Twin Cities and further to the north, and we're just stuck in this. It's cooler here. For reasons that are just kind of an odd corridor of warmth that gets around us but not over us. But and the anomalies for this, speaking of that, I mean, look at this at this time period.
Oh, look at
30-degree Fahrenheit anomaly across parts of Ontario, well to our north, and that week before, when those 80s were there. Look at this. I mean, this is just tremendous.
That's bad for late season fire. I mean, you dry out the prairie provinces or even northern Ontario, and then when the summer thunderstorms come in the ring of fire, and you have elevated lightning, especially in Alberta, and you get these forest fires because you've dried it out in the spring. That's bad news. And we get air quality issues. I don't know if Brad's still here, but we get air quality issues downstream from those Alberta fires if they're extreme. So we're not immune to the consequences of that.
Right, and this is late into May. We got this, and you raised a really interesting question. This will be kind of interesting once we resume some form of instruction next fall with the freshman interest group that Greg teaches. I mean, we have the COVID-19 issue that we're dealing with, and that's a serious health issue and health challenge globally. But if you think about the natural hazards that we're going to be experiencing, we've already experienced with tornado outbreaks in the southeast and central part of the United States in the last couple of weeks. Maybe fires in some parts of the western United States and Canada, and then hurricanes later in the season over the southeast and Gulf Coast. You're going to have significant movement of people because of these hazards or dislocation of people. And how do you shelter in place, or how do you keep the physical or social distancing that's required to keep these outbreaks at a minimum if any of these natural hazards occur and force people to have to congregate in shelters? That's going to be a really interesting challenge, and I'm sure people are beginning to think about this, but just something to consider as we move ahead into the later into the spring. Not to compound all the worries that we have, but this is just something that we have to think about.
Yeah, the New Orleans mayor was talking about that last night with respect to hurricane season. They're trying to put the virus under some control in their city and in their state, and they're making some progress, but 6 weeks from now they have to contend with hurricane season, and then no matter what they've done, they might have to set the clock back. So it's just awful.
Yeah. So, and John, since you mentioned hurricanes, I guess I mentioned them too. Zoe had sent me this link. I just recalled that this is the 204-hour forecast from the GFS from 12Z this morning. The tropics are pretty active in the other side of the hemisphere, in the eastern hemisphere.
Look at that.
Approaching the Philippines, and then approaching the Bay of Bengal is another tropical cyclone forecast by the model. So it looks like the season's ramping up pretty quickly.
I wonder if an early or an active season in that basin puts the kibosh on the MJO. I don't know anything about that. It'd be kind of interesting to know that. Somebody probably knows right off the top of their head because they're experts in the audience. Right. But I would imagine if you got a lot of convective activity whatever it is that forces the MJO might have to take a second seat, you know, when you've got a lot of cyclone activity in the Bay of Bengal or in the maritime continent Philippines.
Right, and closely related to that is how the relationship between these types of events and the predictability over the Western Hemisphere.
Yeah, you
Right,
bet.
particularly this time of
Big
year, to get them early, does that reduce the predictability?
Yeah. Yeah, Scott says early May is not unusual for a Myanmar tropical cyclone, so that's part of their CLIMO, I guess.
Right, Myanmar, formerly Burma, as the New York Times used to say back in the early 90s.
Yeah.
Okay, and Norris mentions that these the velocity potential field is great for tropical cyclones too at this point. So there must be a minimum in velocity potential. I don't know if this is going to come up or not. The link that you'd sent. I guess these are different phases of the MJO, but if someone wants to comment on this, this was just a lot of new Eastern WF weeklies advertise a standing wave over the African and West Indian Ocean from mid-May until June, coinciding with the start of the Atlantic hurricane season. And that puts us, or the Atlantic hurricane season, this is the velocity potential anomaly is negative, which would mean that the largely divergent flow out over the Atlantic. But I think if I look at these latitude, where the latitude lines are, or sorry, the longitudes, maybe in early May over the Gulf of Mexico, which is where the season would first start out, it might be favorable for TC genesis. But the deeper the velocity potential, if you look on the on this chart over the Western and Central Atlantic, is really goes to become anomalously low, which would indicate greater above normal divergence, perhaps. That's not in a region that typically the season's going to be active in that time of year anyway. So
yeah,
it could be more favorable, but you know, what does that mean? So
out of reach, yeah, not operationally relevant, perhaps.
Right, but certainly over the Indian Ocean, that looks like a pretty favorable region. Maybe you're already seeing evidence of that with these really dark blues over the.
Yeah, right.
So this is So thanks for sharing that, Nur. That's really good. All right. Well, thank you everyone for the presentation. Andrew, quickly for a wonderful presentation.
Yes, I agree.
Spirit outlook, John, for as always a wonderful discussion of the past week's weather and the current weather.
Before everybody leaves, I just want to say thank you, John and Michael, for leading this during the semester. I know there has been some interest by people continuing Weather Watch through the summer, maybe not every week, but you know, maybe once a month or whatever. I know John and Michael have both expressed an interest in taking a break, so if any of our students or alumni would be interested in leading a Weather Watch or sharing how the weather is impacting you in your job or anything, whatever, I'm happy to host these even weekly if people are interested in just getting together and talking amongst ourselves about the weather. So if anybody has interest in presenting, shoot me an email. We'll set that up. And if other people have interest in just gathering here and talking, again, like I said, I'm happy. The URL will stay the same. It'll be the same Blackboard Collaborate room, and we can just get together and talk. No pressure on John and Michael, but thank you guys. So
right, thanks,
thank
Pete,
you,
and also
thanks for organizing it all.
Yeah, I just want to note that you created a Slack channel, Weather Weenies, I think it is, or something like that. That's good for weather discussions. It might be a way, so that people, if folks didn't see that, if they want to join to that, there'll be discussions of interesting weather, and that might, trigger a Weather Watch if there's an event of interest that's coming up.
There's some comments in the chat about MJO from Liz and just some other stuff too.
Yeah, I saw that. Do these chats stay around? I mean, are they a permanent fixture, or do they
I believe they are a part of the recording, yes.
Okay, great.
And I download them. So you go back and view the recording of this. I think if you go into, well, I'll have to figure out exactly how to get there, but I do take the recordings of the video at least and post them on our YouTube channel, so they're available. I'm not sure if the chat messages show up on that or not.
Okay.
Right, and here's Isaac's link, and maybe we'll put this on the weather. We will put this on the Weather Watch page as well for the maps that he's creating, and we'll be migrating that over to a different server down the road once things get more stable.
All right, that's really good work.
Yeah.
Thanks for letting me talk, guys. Have a good weekend.
Thanks so much,
Andrew. That was great.
Much appreciated.
Have a good weekend, everybody. Thanks again, Pete, for organizing it. Thanks, Michael.
Take care, everybody.
Thank you. I think, John, what are you up to?